Well, I'm a computer scientist, so I'm mostly interested in data. And what I'm going to be talking about is how to use visualization in my work as a data scientist. So data scientists usually have like very simple troubles. They have data, and you know, you're given a data set. What do you do now? It's not really trivial, right? What I mean is something like that. You get this. And you have a lot of this. Now what? So the trouble is that, you know what, if you get this and you don't know what you have and you have a lot of this, right? Where were you when this was created? So like this is the main question, and there are a few answers to this question. First of all, you can say like, you know, I wasn't there. I was just given that, right? Like I need to figure out still what to do with it. One of the examples, like the real world examples that I have was this data set. It's a very well-known data set. I guess I was the first data scientist who actually touched this data set. And it took me a while to figure out that there were 40% of duplicates in this data set. If I didn't figure it out, you know, like when we removed all those duplicates, the data was completely different. So those are things that we need to figure out before we do any type of analysis, any type of conclusions. There is another problem. Like you do have the data and you are there when the data is being constructed. The trouble is that you don't always have a luxury to ask what this data is all about. Like I was working for LinkedIn, and people are not even good about explaining who they are. And when we ask them, for example, what is your level of seniority? You know what? Everyone is senior. Everyone. So like it makes no sense to ask questions like that. So we need to infer it from the data, even when we are there, when people are doing that. Another trouble is that you have the data and someone created metadata for you. That's the paradise, right? No. So what can happen is that there is so much stuff in this paradise of metadata, and this metadata was created in so like difficult and erroneous way that you just cannot trust this metadata. You have to kind of redo that or clean it or improve it or whatever. And like my talk today, my running example will be patents, the patent world. And if I showed you the metadata of the patent, you know, it wouldn't fit this screen and like about 100 of other screens. So it's just, you know, and people actually classify patents into like 20,000 different categories. It's just not working out. So you still have this problem. You have a lot of data. You need to figure out what you have out there, right? What are the approaches to figuring this out? One is really well known. It's called the cluster analysis. I don't know if you know what clustering is. You basically try to build coherent groups of data points, and you try to kind of figure out what those groups are all about. A few troubles with this approach. There are many clustering algorithms. All of them, most of them are very heavy. So if you have big data and you're running a very heavy algorithm on this data, it just won't finish. What is the solution? It's out there. Parallelization. By the way, our book is all about that, how to parallelize machine learning algorithms. Another trouble, there are at least two more. Okay, now you need to figure out how many clusters you have, because you can, you know, like it's really your system is depending on the number of clusters. That's not trivial. In many cases, it's pretty much impossible. And the last but not least trouble, clustering is just not accurate. So you can find something that might kind of correspond to those coherent groups that you have in your data, but you won't know. It's the big data, right? You get something out of this clustering. What do you have? You don't know. Well, a little bit of an advertisement, right? So there are good clustering algorithms out there. You see my name on a few of them here. So there are good clustering algorithms. You just need to find them. They're pretty heavy, though. Another approach to the same problem. It's classification. Like I'm just basically going through like various machine learning techniques. In classification, you don't just find those clusters like groups, coherent groups. You define categories, you label some data, and you learn a model that takes the entire data set and puts all the data points into those categories that you define. That's how you do classification. So, a few troubles with this one. Who is going to label the data? And how much data you should label? You are talking about like billions of data instances. How many should you label? 1,000? That would be not good enough, right? 1,000,000? How much time and how much money would it take you to label those million data instances? That's quite a problematic way of doing that. So we have a paper that explains how to do classification when you don't have any initial label data. It can be done, it is possible, and it's done like kind of semi-manually, so we were using crowdsourcing and machine learning to figure out the consistency of this classification. It does work, it has a few troubles as well. One of them is that when you ask people to label the data, people can hold like 20 categories, but not 20,000. It just won't work, people just don't remember them, right? Once you have 20,000 categories, which can also happen, the results will be not accurate again. So we kind of coming back to the same problem of clustering. It just doesn't work really well. Back to the same trouble. Have the data. What are we doing? Another approach, which is kind of even more problematic than that, is search. So you take all the data, you index the data, you put it in some search engine, right? And to figure out what you have out there, you just do a few searches. That doesn't work in many cases. One of them is like all those patents issues that I'm going to get closer to it very soon. So you want to figure out what's going on in patents in the world of REUTERS. So this is a patent search, it's not a regular Google search. You put on REUTERS, you get 4 million results. What are those results? You know what? I'm working on this data. It turns out there are about 40,000 patents that have the word REUTERS in them. What is this 4 million results? I have no idea. Besides, okay, you see a patent, you see another one. What's going on in the world of REUTERS out there? I don't know. There is more trouble to that. For example, we want to figure out what's going on in the world of audit. And when we say audit, we usually mean like financial audit, right? And in the world of patents, it's not the case. When you say audit, it turns out that there is like anything but financial auditing. For example, optical network audit tool. So they use the word audit for pretty much any QA system. How would you know? If you type in financial audit, you find 6 patents. And believe me, there are many more than that. So like it's just not, it doesn't let you the tool to figure out what you have on your data. There is a solution. We are proposing a solution. It's not perfect. It's kind of better than what we have out there. So it's some type of a combination of clustering and search, and it is built on visualization. And it's not cheap. But if the data is static, you can do much of the processing offline. And I can't claim the novelty out there, but I can claim the accuracy. It's an accurate approach. And it's built on building the semantic network of your data. So basically you take, in our case it says 7 million patents, and you build a network. Think about like Google Earth of patents, where the cities are patents and the roads are semantic relationships. 2 patents are sitting close to each other if they talk about a similar topic. How to build this thing? This is what we're doing, essentially. One trouble is that you need to do 7 million by 7 million comparisons. It's 25 trillion comparisons, guys. It's not negligible at all. We are smart enough not to do 25 trillion comparisons, but you know, we're definitely getting into billions. And the solution is parallelization. We are good at it. Another trouble. Okay, so we have the graph, but we cannot visualize it. It's just too big. 7 million data points, it just won't fit your screen. It won't look good, right? So we kind of ended up with pretty much where we are, but with probably one thing. You can visualize portions of it. And this is actually very, very powerful. So basically what we can do is we take the entire semantic map of all the patents available by USPTO. It's 7 million patents and patent applications, actually. And we can drill down to any region, basically cut around something, and you can see the visual representation of whatever is sitting out there. And here's an example. So we took a company called eBay. I guess you guys know that one. So we took all their patents that we found back then. It was 550 patents of eBay. So what we did is we cut around an area which contains all eBay patents and all the patents that surrounding eBay semantically. So they're talking about similar things. So we ended up with 250 non-eBay patents on that map, and that's how we present it. And that's a mess. But Gephi is a great tool. You press a few buttons. First of all, it shrinks down to clusters. Every green dot here is in eBay patent. And the red dot is a patent on someone else, not eBay, that is very closely semantically related to a patent of eBay. And then, look at it now is going to be, it's now kind of, it's going to expand. And out of the sudden, you can tell stories. Look at that. Here's an area where eBay is just controlling it. No one can get inside. No one can sue eBay on anything here in this area. I have no idea what this area is. I don't care. eBay doesn't have to care because they're kind of protected from all the different perspectives. Versus, look at this one, for example. That doesn't look good. 4 green dots surrounded by red guys. I don't know. Out of 550 patents on eBay, we can find 4 patents that kind of don't look good. And look at this guy. You see 4 red guys and quite a few green guys. This doesn't look good at all. The amount of interconnectivity here tells a story. And there is a story. You know what? You can just go to Wikipedia and read this story. There was a guy named Thomas Woolston who wrote patents, sued eBay, received $25 million. I don't know that, and you guys don't know that. We just look at the graph, we see this, we say, something happened out there. So guys, we can tell stories about companies just to, when we look at pictures like that. How much time do I have? Good. You want to see the map of Apple? That's many more patents out here. And you immediately, like, you know, your eye is attracted by something like that, right? You know how this is called? What's the name of that? You call it paranoia. I have no idea why Apple issued so many patents on a particular topic. And I don't even know what the topic is. I tried to figure out, I couldn't. But they really were very particular about issuing more and more and more and more patents on this area. They care about it. We don't know. We just look at the picture and we figure that out. And by the way, There are a few red dots here. Those are patent applications issued on the name of Apple engineers. So those patents are Apple. All of them are Apple. They really want to make sure that no one can touch this area. You know how this is called? Apocalypse. That's called the war. Yeah. So yeah. So there is an ongoing litigation in this area, and you know what? Just from the graph, from the the amount of green dots and red dots, Apple doesn't look good. I don't know. Probably they will win. I have no idea, right? But just visually, it just doesn't look good. And look at this area. Look at that. You know how this is called? It's called the nightmare. You know why? When people create clusters like that, they know what they're doing. It's one company that builds so many close patents. No one can sue anyone in this area. Versus this area, when the cluster is kind of scattered and sparse, it can be created organically. Meaning, Apple is writing patents, someone else is writing patents in the same area, and they just happen to overlap. Guys, this is very scary. There are like millions to billions of dollars in areas like that. If someone starts suing someone, someone gets in trouble. We don't know again. You are not patent people. I'm not a patent guy. I'm a data miner. Just looking for patterns in maps like that are telling us stories. So there are quite a few stories here. And if I were a patent person, I would just, look into each and every cluster here and figure out what's going on. You can tell a lot about a company's R&D strategy and IP strategy just looking on those graphs. And by the way, this is not dynamic. Think about that it can actually create with time, right? It's not that very difficult to do. I am just not doing it yet. Then we will have many more stories to tell. And by the way, Apple is not the company that is going so public about their R&D strategy. Not really. And this is a publicly available data. All the data is completely publicly available. You can tell about what's going on inside the company. How much time do I have? Huh? 5 minutes. Okay, good. Yeah, I just wanted to show you that actually we can look into some areas that are not only related to companies, more like for areas that are like broader than that, for example, financial audit. And this is more complex, right? Because it's very easy to define the area of patents of a certain company. It's just, either the company owns the patent or not. When you define an area of interest like financial audit, it's much more complex because you don't really know where the boundary is. So it's not easy to do that, but we can do that. And maps look like that, more or less. And once you have a map like that, you actually can do quite an easy analysis of what's going on in the world of financial audit and patents. So there are like 10 major clusters, more or less. You choose one central patent here, one centroid. You look through it, you understand what this patent is all about, and you have a good notion of what's going on in the area of financial auditing in patents. You can visualize them differently, like for example over time, and see that out of the sudden, since 2009, there is a big boost in audit-related patents. You can say who is the main player here, and stuff like that. Probably, like just for the end, I wanted to show a few visualizations of patents that people were doing previously. Over here, they were playing both with colors and the shapes. This is the graph of citations, who cites whom. We are doing much better than that, obviously, because the citations are very biased. Like companies decide whom to cite, not because they want to cite it, because they probably don't want to cite it. So this is the data that you cannot really trust from the semantic point of view, but you can visualize it still. There is a company Innography that builds like maps like that, more like a city map, and they actually give some names to particular areas. And I would say that those names, I don't know, what is data packet? Not really an area of, you know, it's not a research field, right? It's not really accurate. So there are problems with that, but people try to do that. And Thomson Reuters actually try to build beautiful visualizations, like it looks totally stunning, but I am not sure how useful it is. Oh, here's a, sorry for the quality, that's the map of Google patents. There are so many patents out here that it's hard to see, but look at this area, that's all green. Google controls an enormous area in the patent world that no one can approach. This is something that is interesting to know, and by the way, I can tell quite a few stories about like different regions in this map, but I just, I'll skip it for the sake of time. Thank you very much. One thing that I wanted to say is that I'm teaching data science at the University of Haifa. If you're interested in the master's program in data science, come talk to me.
We have time for questions.
Hi, Mushan from Shenkar. So you showed us some speculations about possible conflicts of patents based on this network diagram. Could you use a similar diagram to explain to us an existing patent war? Because you pointed at things that could be dangerous, but did you try to use to do it the other way around, to know about a patent war and then try to track the data behind it?
Yeah, I actually try to. It's a very funny situation. So what's going on in this world is that companies are being sued not on patents that are close enough, but on patents that someone found and decided that they are close enough. So what I claim is that if you use this tool for suing guys, you can find the particular patent that is most dangerous, not the one that someone found in the area of 7 million patents. So that's quite a dangerous tool, actually.
So do you know if this approach is actually being used to litigate?
Yes, I know, no. It's not used because we are controlling this work, and we are not going to let bad people access it. Really, guys, there are millions of and probably billions of dollars out here. We need to be careful. I'm not kidding. Thank you, guys.